Hello everyone, thanks for joining us. I'm really excited to share with you a new feature in Amazon EMR that we've been working in collaboration with some of our partners at AWS. My name is Gopinathan Kannan and I'm an engineering manager in EMR. In this session, I would like to provide an overview of Amazon EMR on Amazon EKS, talk about some of its key features, walk through an example that shows how the feature works, and highlight some of the security controls that we have built into the feature. So what is Amazon EMR on EKS? It is a new deployment mode that allows you to run EMR on EKS managed Kubernetes clusters. This is in addition to existing deployment modes where you can run EMR on EC2 that is managed on AWS Cloud or on-premise using AWS Outpost. Our goal for this feature is to provide a managed experience for our customers so you can run Spark application on Kubernetes easily and securely. Now, why did we build this feature? Spark continues to be one of our largest drivers for big data applications. Whether it be ad hoc queries, production-grade data pipelines, or data science experiments using notebooks. When talking to our customers, we found that they had non-trivial amount of work to do in managing different types of infrastructure for different types of application. They wanted to consolidate and simplify infrastructure management across their organization. They wanted to do so without losing the ability to manage resources by logical separation, such as teams, or by the type of application workload. They wanted their analytics jobs to start quickly without any significant provisioning delays. They wanted the analytics jobs to be resilient, whether by choosing availability zones or spread across multiple availability zones. In addition to these, the ability to burst their compute capacity on demand using serverless technologies like Fargate would be a tremendous value add. Now, Amazon EMR on EKS allows organizations to achieve these by letting the data scientists and engineers do what they do best, focus on the business logic to deliver business insights faster. To understand the feature better, let's take a moment to understand how EMR on EC2 works. EMR on EC2 is a versatile framework that allows you to choose your infrastructure configuration. This control drives a cluster-centric model where a cluster typically runs a single version of Spark to avoid dependency collisions. This provides you great value when you're able to right-size your cluster and achieve higher utilization. With EMR on EKS, there are no more clusters to build specifically for your analytics workload. We containerize the Spark runtime so applications can quickly run on an existing EKS cluster. This allows you to run multiple versions of Spark on the same cluster and allows us to build a security model that is job-centric. Now, teams can stay agile by making quicker updates to both the application and the runtime. You'll also be able to consolidate resources into a single cluster and improve its overall utilization. And such consolidation drives cost savings. Even if you are simply to take your existing resources and pull them into a single EKS cluster, you should be able to reduce your cost or get more work done, as illustrated in this example. With EMR on EKS, you can get to these benefits faster. EMR will provide you with a distribution of Spark with recent features and bug fixes. It will help you manage the job lifecycle and help you build jobs that are secure, complying to the principles of least privilege. It will help you build jobs faster through its native integration with AWS data and analytics services, and build jobs that are of production quality with easy debugging capabilities. And finally, help you move to production through integration with orchestration services like Apache Airflow. In addition to these, EMR provides a differentiated performance over open source through its native runtime capabilities. We ran our benchmark against TPCD's 3 terabyte dataset, and we consistently saw a 2x performance improvement in GeoMean over all queries when running with EMR Spark runtime on Kubernetes. It is understood that the results may vary on the attributes of your specific workload, We encourage you to try it out for yourself, and we anticipate that you should be also able to experience similar performance improvements, which would further help drive costs down. Speaking of cost savings, let's dive a little bit into pricing. What we wanted to do is for you to pay only when you're using resources and running a job. So if you're not running a job, you do not incur any EMR costs. Now, costs are based on how much vCPU and memory each pod utilizes over its lifetime. We have priced it at a cent per vCPU hour and 1/10 of a cent per GB hour. The pricing is per second and a 1-minute minimum. The total cost of ownership also includes the EKS cost that is priced per cluster. And you also pay for resources such as EC2 instances and Fargate pods that provide compute capacity for the Kubernetes worker nodes. To get started, let me introduce the core constructs in the feature. First is a virtual cluster. That is a registered handle to a EKS cluster and a Kubernetes namespace. In Kubernetes, a namespace is defined as a virtual cluster backed by a physical cluster, which is intended for use in environments with many users as a way to divide cluster resources between teams and projects. We carry that notion forward into EMR with EMR virtual clusters construct. This has a one-to-one relationship with Kubernetes namespaces. The second is a job run. It simply represents a Spark job that is being run and managed by EMR. The third is a managed endpoint, which we are previewing along with EMR Studio as a way to construct and connect your notebook to a EMR managed endpoint on the EKS cluster. More on that later. Now, creating virtual cluster is easy. You give it a friendly name, you specify the EKS cluster name in the account, and specify the namespace that is being provisioned for EMR to use. Running a job is equally easy. You give it a friendly name, you specify where you want the job to run in terms of the cluster ID, you specify the IAM role that the job should use when running on a pod, choose the EMR release label, specify the job driver, which includes the entry point file and its arguments, and the Spark submit parameters. You may choose to override application configuration. We use the same classifications that you may already be familiar with in EMR. And here are some examples of the classifications that we will support. Now, you can also provide additional monitoring configuration as part of a configuration override. We support application logs to your CloudWatch logs and also pushing application logs to a specified S3 bucket in your account. Now, let's take a deeper look on how it all works. We start with the EKS cluster and EMR, which has pre-built images for different releases of Spark runtime. An EKS administrator would provision the cluster and create namespaces if necessary. Then the EKS administrator will register the namespace with EMR as virtual clusters. Once registered, data engineers and scientists who are authorized to use this virtual cluster can submit jobs. When jobs are submitted, EMR will initiate the Spark pod to start the driver and executor pods. If the image is not on the local node, Kubernetes will download the image from the EMR repository and start the pods. More users can use the same virtual cluster or a different one to submit their jobs. They can provide Spark configuration to also select nodes by availability zones. Once the jobs are submitted, EMR will monitor the jobs on a regular basis. Users can get the status of the jobs by using the list and describe APIs, and job runs can be tagged to help separate job runs by user or team. It can also be used to control access to who can submit jobs and who can describe or list jobs on a virtual cluster. Once the job is complete, the pods are deleted from the cluster. When all jobs are on the cluster are complete, EMR will stop monitoring, and the EKS cluster is back to the state where no resources are used and no jobs are running. The virtual clusters are available for reuse, and however, if administrators decided to do so, they can clear out the virtual cluster by deleting them from EMR and optionally the namespaces as well. This takes the cluster back to the state where we started. For job submission, you have several options. We already looked at the option of using CLI. We also have the SDK for you to be able to programmatically do the same. We'll also release an Airflow operator that will make it easy for you to manage job runs as part of your data pipeline. We're also working in integration with AWS step functions that will provide you with similar capabilities, which is coming soon. For job monitoring, we already covered the ability to upload logs to your CloudWatch and S3 buckets. While these are great tools, we also built a one-click experience with AWS Console and EMR Studio. On AWS Console for EMR, you can see all the virtual clusters under EMR on EKS. By selecting a virtual cluster, you can see all the jobs that were run on that namespace. You can simply click View Logs to see the event log in the Spark History server. Similarly, on EMR Studio, you can see the list of jobs under the virtual clusters and select a job and launch the Spark History server to get the same UI experience. The way this is different is that this is really useful for organizations where data engineers and scientists may not have console access and can use their personalized workspace on EMR Studio to debug job failures. For interactive notebook experience, we have integrated with EMR Studio to provide you with an option to run notebooks using EMR on EKS. This feature is currently in preview. To use this feature, first, you would create a managed endpoint. To create an endpoint, the process is very similar to job runs. You give it a friendly name, specify the virtual cluster where the endpoint needs to be set up, specify the execution role to be used for interactive workloads that run the endpoint, choose the release label, and choose the type of endpoint. At this time, we support Jupyter Enterprise Gateway as one of the options. And finally, the certificate ARN that will be used by the application load balancer to secure the connection should also be specified. Note that you can provide configuration overrides to override the application configuration or monitoring configuration optionally, similar to how we do with jobs. Here's an example of a snapshot where on EMR Studio, when creating a workspace, you can attach the workspace to an EMR on EKS cluster. Once it's attached, Kubernetes-based kernels are available for use, and you can select one of them to submit your notebook directly onto Kubernetes. Now let's take a quick look at these features.
For this demo, we already created an EKS cluster with a few EC2 instances. We also created a namespace and pre-provisioned it to work with EMR on EKS. We will now create a virtual cluster using the Create Virtual Cluster API through the CLI and give it a friendly name. For container provider parameters, we'll supply the name of the EKS cluster and also specify the namespace that this virtual cluster will be associated with. Now let's go ahead and create the virtual cluster. Once created, you will use the ID to describe the virtual cluster, but you can also use list all virtual clusters that are registered to the Kubernetes namespace on the EKS cluster. Now, in addition to the supplied input, here you can see the ID, assigned ARN, and the state of the virtual cluster. Now we are ready to run jobs. As mentioned earlier, running jobs is easy. You specify where you want to run the job, give it execution role on, specify the EMR release, and the job driver parameters. These are the required configurations. Now let's submit a simple job. As you can see, we have supplied all the required parameters, where the job will run, under what role, and which EMR release to use. And we'll do a Spark submit using the simple SparkPy application that comes built into the image. And we are given configuration override, which has both the CloudWatch monitoring configuration and the S3 logging to a specific location in your account. Now let's run this job. You can go to the console to look at the status of the jobs. Logs are pushed on a continuous basis. So you can go to S3 and also look under that particular URI. Here you will find that the logs are organized under the virtual cluster, then jobs and job ID. And in here you will find both the driver and the executor logs, and you can download them if needed. You can also go to CloudWatch logs for the specific log stream and use the prefix to filter the job specific driver and executor logs. And directly look at the output of the application log. So in addition to these, if you go to the console, you can get a simple one-click experience for viewing logs. This will load the Spark history server where the logs are rotated frequently. So this will give you a near real-time view for running jobs. Now we'll cover the use of Airflow operators for job submission. This is a simple pipeline that uses the New York taxi data. It converts the data from CSV to Parquet and computing the daily trip count, encrypting the results, and sending it to S3 for further processing. Now let's trigger this pipeline. The first step will start the job run. The green box means it was successfully started. So you can look at the Airflow logs to see the job ID. There. And the virtual cluster it was submitted on. And as you can see on the console, the job is currently running. Now the next step is a sensor, and it continuously polls for job status using the describe API, and the status changes to completed. Then the pipeline will move to the next stage. Now let's take a look at how notebook experience using EMR Studio works. EMR Studio is in preview. Now EMR Studio users will first create a workspace. As part of the creation process, you can attach a notebook to the EKS cluster and the endpoint under advanced configuration. We have already created a manage endpoint for the purpose of this demo, and the endpoint also has the same monitoring configuration that we have used in the when running jobs. So once created, the notebook in the studio will be able to securely attach to the managed endpoint, but this will take a few seconds. So let's pick a workspace that's already been attached to the same endpoint. Now you can create a PySpark notebook. Now here we have a simple example. As you can see, the notebook is already attached to the endpoint and the running Spark kernels through the endpoint. Now let's run this notebook. And we'll see the result of the execution. We also support commonly used libraries like pandas. So here's an example of Amazon book reviews from the public S3 repository. We already preloaded the data with about 20 million rows and 3.5 million books. Now we can quickly plot this data using matplot library. Let's run this. Now for quick debugging, you can jump to the Spark UI from the notebook, where you can see all the jobs that were run in this notebook context. As mentioned earlier, the managed endpoint is also configured to push logs to CloudWatch in S3. So here are the CloudWatch logs. And here are the S3, here's the S3 bucket where the folder structure is very similar to jobs. Under the virtual cluster, you'll find the endpoints and the ID of the endpoints that you are interested in. And for each endpoint, you see the set of applications that were ran. And you can select an application to get to the executor and the travel logs. Now going back to Studio, you can see multiple workspaces can be attached to the same endpoint. And also you can create a workspace without attaching to a managed endpoint to begin with, but rather attaching and detaching to any authorized endpoint for the user only when they see the need to do so.
When building this feature, we added several security controls to help you run jobs in a secure manner. At the same time, we wanted to make it easy for you to configure these controls. Let's highlight a few important ones. An EKS administrator must explicitly enable access for EMR to access a namespace within the EKS cluster. Now, this involves creating a Kubernetes role, an identity, allowing EMR scoped permissions to run jobs and set up endpoints on the cluster, and then map that identity to the IAM role corresponding to the EMR service role. Now, to make all this easy, we worked with our partners in EKS to update EKS CTL. To set up the cluster for EMR access, you simply provide the cluster name, the namespace, and pass EMR containers as the service name. Another important step is for an administrator to explicitly allow IAM roles that will be used as job execution roles on a particular namespace. Now, since we use a Kubernetes feature called IAM roles for service accounts, administrators are required to create a trust relationship between the IAM role and the identity of an EMR managed service account. These service accounts are also scoped to a namespace that belongs to a cluster. To make this all easy, we have added a utility function in our CLI, which will take the cluster name, the namespace, and the IAM role. With this, you are able to create the trust relationship. Administrators can also control which roles can be used on a virtual cluster to run jobs. To do this, administrators create a role with condition key EMR containers execution role on with a list of allowed execution roles and attach it to the identity of the job submitter so that the job submitter can assume that identity and submit jobs using those execution roles. In addition to these special controls, you can also use tag-based access control for consistent authorization experience, which is now a standard across many of our AWS services. Now, to summarize, EMR on EKS is a new deployment mode in EMR that allows you to run Spark on EKS clusters. With this feature, you'll be able to consolidate infrastructure across your organization, manage resources by teams, projects, and workloads, start jobs quickly without provisioning delays, run jobs in a resilient way by choosing between AZs or spread across AZs, and choose to run in a serverless way using AWS Fargate or EKS. So thank you for joining me on behalf of the team that's behind bringing this new feature. I can say we are very excited to share this with you, and we are looking forward to supporting you in the near future. Thank you.